Hello, Assalamu alaikum. Today, I'm starting uh, a new series of past papers of Physics 9702, A levels physics, AS physics, and the topic is kinematics and dynamics combined. In this playlist, I will focus on dynamics, whole momentum, and all, and kinematics, including projectile motion. So I'm starting from 2024, all variants that I'm going to cover in this section. Okay, so this is first question from May June 2024, paper 2, variant 1. And the first thing that they are asking here is define velocity. And if you have studied this topic, this is this was in O levels as well, that velocity is change in displacement per unit time. Now, a student throws a ball over a vertical wall of height h, as shown in figure 2.1. It appears to be the question of projectile motion. Okay. The ball leaves the hand of the student at a height of 1.2 meter above the ground. The ball has initial velocity of 22 meter per second at an angle of 40 degree to the horizontal. The ball is a horizontal distance 36 meter from the from where the student releases the ball. So this is the point from where the ball is released. The initial speed is 22, which is the resultant speed, neither horizontal nor vertical. And the angle that it is making with the horizontal is 40 degree. Height of this ball at the starting at the launching point is 1.2 meter, and the horizontal distance from the wall is 36, and the height of the wall is h. So air resistance is negligible. Um, okay. Determine the time taken for the ball to reach the wall. So how long the ball is going to take to reach the wall, that is here. Okay. We need time. It is 2 mark question. So here, what we have the horizontal distance 36 meter, and um, we have resultant velocity and angle. So we have a formula here that horizontal distance is equals to speed multiplied by time. And here the speed will be horizontal. If you have studied this topic, you know that for horizontal motion, we have only this equation, distance is equals to velocity multiplied by time. And if you are solving vertical section, then for vertical section, we have the other equations of motion, SWOT equations that we can use. But for the horizontal section, we use only S is equals to Vt because horizontal velocity is constant and vertical velocity changes. That's why we can use there all other equations of motion, but not here. So first of all, we need the horizontal velocity. The formula to calculate horizontal velocity is V cos theta. So horizontal velocity will be 22 into cos 40. So distance 22 into cos 40, it is 16.86. Now, distance is 36, 16.86 into time. So, time from here, I will get 36 divided by answer, and I'm getting 2.136. 2.136. So, in two significant figures, it will be 2.1 seconds. I hope it's clear. Calculate the vertical component u of the velocity of the ball. Okay, so vertical component is v sine theta. So here they are calling U, the vertical component, initial velocity is 22, which is resultant, and sine 40. 22 into sine 40, which is 14.14. In two significant figures, it will be 14. Now, the ball just goes over the wall. Calculate the height h of the wall. Now, they are asking to calculate the height of this wall. What we already have here is the time it will take to reach this point. And yeah, one thing that we can do, what we can do here, we know this height is 1.2 meter. If we calculate uh, this height, we can find the distance, vertical distance, and by adding both of them, we will get the total height of the fall. So initial vertical, here I am going to use equations of motion. Initial vertical velocity is 14.14 meter per second. Time that it will take to reach that wall, I have already calculated 2.136, and distance is required. Since it is upward motion from the starting point, it is going upward from this point. So acceleration due to gravity will be negative, and air resistance is negligible. So acceleration is minus 9.81. Now S is equals to ut plus half at square. So S is required. U is 14.14. T is 2.136 plus half minus 9.81 into 2.136 square. So if I calculate this, this will be 30.20 minus 22.379. If I subtract 7.82. So it means this vertical height that it has covered, this is basically 7.82. So if I want total height, it will be 7.82 plus initially the height was 1.2. 1.2. If I add 7.82 plus 1.2, I'm getting 9.02. So it will be 9.0 meters. So this is the other question from this paper, and this is from the topic momentum. State the principle of conservation of momentum. So principle of conservation of momentum is if resultant force is zero, total momentum of the system before collision is equal to total momentum after collision. Now, An object of mass 2m is traveling at a speed of 5.0 meter per second in a straight line. It collides with an object of mass 3m, which is initially stationary, as shown in figure 3.1. Okay, we can see here the object with mass 2m, it is moving towards right with a speed of 5.0, and this object of mass 3m, it is right now at rest, and this one with 2m is going to collide with the right one, having the mass 3m. After the collision, the object of mass 2m moves with velocity v at an angle of 30 degree to its original direction of motion. So it is shown here. The object of mass 3m moves with velocity w, also at an angle 30 degree as shown. So this was the object with mass 2m, which was coming this way, and its initial velocity was 5.0 meter per second when it hit this ball object. So both are going at 30 degree to the initial path of the mass of 2m. So this is given in the diagram. By considering the conservation of momentum in two dimensions, calculate the magnitude of v and w. So this is v after collision, this is w after collision, which is required. You know, velocity is a vector quantity. If velocity is a vector quantity and it is at particular angle, so it has two dimensions. It's vertical dimension and horizontal dimension. So what we have to do here, we have to convert it into its components. So first I am doing here that converting it into its horizontal and vertical component. This will be the horizontal component of this one. It will become v cos 30, and this is w cos 30. I'm writing it here. W cos 30. And if I calculate the vertical component, then for vertical component, this is the vertical component of V sine 30, and this is the vertical component of W, and it is will be W sine 30. So these are the components. Now we are required to consider the conservation of momentum. As we can see here, that initially the object with mass 2m was moving towards right and it collides with the mass of 3m, which was stationary. So along horizontal, momentum before collision, momentum is mass into velocity. So initially the momentum is mass is 2m and velocity was 5.0, and the other object with mass 3m, its initial velocity is 0. Then after collision, if I'm talking about horizontal, so in horizontal, the object with mass 2m has the velocity v cos 30 plus the object with mass 3m has velocity w cos 30. So if I calculate it, 2 times 5 is 10m. This will become 0. Cos 30 into 2 is 1.73 v mv, because m is also here, plus 3 into cos 30, it is 2.598 or 2.6. 2.6 mw. If I take m common, m will be cancelled out. It will become 10 is equals to 1.73 V plus 2.6 W. So this is my first equation. Now what I am going to do here is I am now applying law of conservation of momentum across or vertical component along vertical. So if I apply the law of conservation of momentum along vertical, so initially Initially, the ball is moving horizontally. The mass 3m, the object with the mass 3m, and other ball was at rest. Both are moving in. First ball is moving in horizontal, and the other is not moving. So if I see the vertical plane, in vertical plane before collision, there is no momentum because ball object with mass 2m was moving horizontal, so it was not in the vertical plane. So its momentum in vertical plane is zero, and the object at rest has also zero momentum. So before collision, the momentum is zero, and after collision, I'm considering upward direction as positive. So after collision, the mass of 2m has a vertical component of velocity v sine 30. So 2m into v sine 30. Then the other component, that is the component of w, it is downward. So I have to take it negative. So it will be minus 3m w sine 30. So from here we can see 2 into sine 30 will become 1, or the negative side will come here, it will become positive. 3 over 2 mw mv. M will be cancelled out by m, and by here I can see that v is equals to 3 over 2 w. I can substitute this in equation 1. So equation 1 will become 10 is equals to 1.73 into 3 over 2 plus 2.6 W. If I solve this and find W, so 1.73 times 3 divided by 2, 10 minus answer divided by 2.6. This is all maths now. It is 2.848, and now 10 plus 1.7, 10 equals 1.73, or you can say use it like this. Since I know W, V is equals to 3 over 2W. So V will become 4.27. So final answer will be 2.9 for W, and 2.9. Okay, I've made some mistake here. It's 3 over 2 W. So now if I solve this, it will not be this answer. So it is 1.92, and 3 over 2 into 1.92, I'm getting 2.89. So it will be 2.9 for V, and for W it is 1.9 meter per second. So it was calculation error. An object of mass 4.2 kilogram is traveling in a straight line at a speed of 6.0 meter per second. The object is brought to rest in a distance of 0.050 meter by a constant force. Calculate the magnitude of this force. So this is the distance covered by the object initially. Its speed was 6, so initial speed is 6.0 meter per second. Final speed is 0 because it is brought to rest, and the distance that it covered is 0.050 meter. So force is required. First, we have to calculate acceleration, which is, v square is equals to u square plus 2as. So v is 0, u is 6, and distance is 0.050. If I calculate this, it will be 720. So acceleration here is minus 720 meter per second. Its deceleration, it's obvious that it will be negative. So force is mass times acceleration. Mass is 4.2 and acceleration is 720. So 720 into 4.2, 3024. So force is 3024 here. So it is 3000 Newton. Now, a skydiver jumps from, okay, we'll do it in the other part of the video.